Today we're going to talk about the properties of midsegments. And I introduced you to midsegments last chapter. I think we were talking about altitudes and all those things. But I'll review what that is. So a midsegment happens in both a triangle and a trapezoid. In a triangle, the midsegment connects the midpoint of two sides together. So this red line here is the midsegment. Okay, so it goes from midpoint to midpoint. The midsegment of a trapezoid connects the midpoints of the legs. Okay, so there's not one going from the bases. Okay, so it's only connecting the midpoint of a leg to the midpoint of the other leg. All right, so we're going to look at some properties with these. So we're going to start with triangles. So here's what we know. With triangles, the midsegment is parallel to the third side. Okay, so that means that DE in this case is parallel to AB. Okay, so that's always going to happen. So it's always parallel to the third side. The third side is the side that is not connected to, basically. Okay, the other thing that happens is that the midsegment is half of the third side. Okay, so for instance, if AB is 20, DE then, since it's the midsegment, will be 10. Okay, that's all there is to it. The midsegment is always half. So let's look at this example. It says FG, GH, and HF are all midsegments. So all three of these little segments here are midsegments, meaning G is a midpoint, H is a midpoint, F is a midpoint. It gives us that FG is 9, GH is 7, and CD is 24. So this whole side is 24. All right, so let's start with our midsegment FG. So if FG is 9, that means the third side, so the side that's parallel, right here has to be twice that. So it's got to be 18. So this has to be 18, which really means this part's 9 and this part's 9. Because remember, H is a midpoint. Okay, so if we look at GH is 7. GH is 7. So that means that CE, that's the third side, would have to be 14, or each of its parts has to be 7 and 7. Okay, for the last part then, if CD is 24, G here has to be my midpoint. So that means each half has to be 12, which means that the midsegment then has to be half of 24, or again, 12. So now it says, find the perimeter of the large triangle, basically. So I need to take 24 plus 18 plus 14. Okay, so 24 plus 18 plus 14 gives me 56. So the perimeter equals 56. Okay, so every time, really, if you notice your midsegment, that value is twice, or you see it twice on the third side, right? So it's going to be 7, 7, and 7, or 9, 9, and 9. All right, so think about this. Here's another midsegment of a triangle. So that 6x plus 31 is my midsegment. It is half of that third side. So I would really need 2 of the 6x plus 31s to equal 19x minus 36. Okay, now there's another way to do that, and we'll talk about that in a second. So let's finish this here. So I'd have 12x plus 62 equals 19x minus 36. If I subtract 12x from both sides, I get 7x. If I add 36 to both sides, I get 98. Divide both sides by 7, and I get 14. I get 14. All right, so that's one way to do it. The other way we could do it is I really only need half of that third side. So I could have done 6x plus 31 equals half of that third side. But honestly, I didn't want to do the fractions. So that's why I doubled the midsegment. But either way, you're going to get your answer of x equals 14. Oops. All right, here's one where we want to look at the angles. So keep in mind, if we have parallel lines, which we do, don't forget we have corresponding angles, we have same side interior angles, we have all of that stuff here. So this shape right here is really a trapezoid, right? Or if you want to think about just the parallel lines in a transversal, these two angles here are the angles between the parallel lines, so those are same side interior, which means that they are supplementary. So 180 minus 59 is going to give me 121 for angle 5. Okay, now this 59-degree angle and 4, these are corresponding. So they have to be the same measure. So that means angle 4 here has to be 59. Let's look at angle 2. So we know that these two angles together have to be supplementary, right? Because they're a linear pair. So 180 minus 127 gives me 53. So this is 53, which also means that angle 1 has to be 53 because they are corresponding. Now, notice I have a big triangle. I have this big triangle, and I also have this little triangle, but they both share angle 3. So it makes sense that the two base angles are going to be equal to each other, right? 53 and 53, and 59 and 59. So if I take 180 minus 53 minus 59, I get 68 degrees. So this angle here is 68 degrees. All right, so there are actually 3 mid-segments in every triangle. Okay, because I can combine, or I can find midpoints of each side and connect to all of those. So something I want you to think about here is, let's look at that third side in the mid-segment. So let's look at the 1 tick mark and the 1 tick mark side, this right here and right here. Okay, the mid-segment that's parallel to this would be this piece right here. So for instance, if this was 12, each half would be 6 and 6, and that's also the value of that mid-segment. So this side would need 1 tick mark. Okay, the side with 2 tick marks. So this side over here, we have 2 tick marks, 2 tick marks. So this side here, the parallel side, or the mid-segment, if that's my third side, then this also has to have 2 tick marks. Okay, same thing is true for the last one then. If I have 3 tick marks, its mid-segment then has to have 3 tick marks as well. So the reason I point this out to you is we've actually created 4 triangles, and all 4 triangles are congruent by side, side, side. So it's just something kind of cool that happens. All right. Now let's talk about the mid-segment of trapezoids. All right, so for the mid-segment of a trapezoid, the mid-segment, again, remember it takes the midpoint of a leg and connects it to the midpoint of the other leg. Okay, so the two bases are automatically parallel because it's a trapezoid. The mid-segment is parallel to both of the bases. Okay, so we actually have 3 parallel lines. Okay, we have 3 parallel lines, which means we're going to have those corresponding angles again. We're going to have same side interiors, right? So to find the length of the mid-segment, you find basically the average of the bases. I had a typo here. You need to put this word in here, bases. Okay, so it's the average of the bases. So for instance, if I had, let's just do something easy, 10, oops, sorry, wrong pen. If I had 10 and 20, I would need to find the average or the middle of 10 and 20. So I would take 10 plus 20, divide it by 2, always by 2 because we only have 2 bases, gives me 15. So the length of the mid-segment would be 15. All right, so let's first of all, let's look at angle A here. So I'm going to know how many degrees is angle A. Well, keep in mind if my lines are parallel, those are going to be corresponding. So A has to equal 55 degrees. All right, to find the length of the mid-segment then, I need the average of the 2 bases. So 10 plus 16 divided by 2, that's 26 divided by 2, or 13. All right, so the next one, we can do algebraically, but there's actually a faster and easier way. Before we do that, I want you to notice if I went from 10 to 13, that's an increase of 3. From 13 to 16, that's also an increase of 3. So whatever one step does, the other step has to do as well. So let's think about this logically. If I go from 16 to 22, that is an increase of 6, which means if that's going to be exactly in the middle, it's going to be an average, I need to increase by 6 again. So 22 plus 6 gives me 28. All right, so algebraically, here's how it would have worked. If I say 16, the two bases added together, so 16 plus x divided by 2, that should equal my midsegment, which is 22. So I need to multiply both sides by 2 in order to clear my fraction. So I'd have 16 plus x equals 44. I need to subtract 44 from both sides. I'm sorry, subtract 16 from both sides. So I get x equals 28. So we end up with the same value. It's just a lot less work to get it just by using logic. And we can do logic with numbers. What we can't do logic with is sometimes with expressions. So let's do the first one on the left here, because that one still has actual numbers. So 5 to 9 is an increase of 4. To go from 9 to the base, I have to increase by 4 again. So that would give me 13. All right, for the last one, we can't really use logic. We are going to have to use the algebraic formula. So I need to add my bases together and divide by 2. So x minus 3 plus 2x minus 2, divide them by 2. That has to equal my midsegment, which is x. So adding my two bases, dividing by 2, will equal my midsegment. So I'm going to combine like terms. So I have 3x minus 5 divided by 2 equals x. Multiply both sides by 2 to clear my fraction. So I have 3x minus 5 equals 2x. If I subtract 3x from both sides, I'm going to have to go up here. If I subtract 3x from both sides, I have negative 5 equals negative x. So therefore, x has to equal 5. Okay, so again, the math isn't hard, and I showed a lot of steps that you don't really have to show. You could have added all of this in your head. You can multiply both sides by 2, like in the beginning. So, again, I showed you a lot of steps that you don't have to do. Okay, so for homework, you have 2 worksheets I stapled together. There are 4 mazes, but most of them are incredibly fast. So I know it looks like a lot, but 2 of them I bet you will get done like in about 3 minutes. So they're not bad at all. And then 2 of them have more algebra on them. Okay, so just bring that back with you tomorrow. If you truly can't get it done, it'll be all right. I would try, make sure you get some done from each page though, that way you have a variety of problems.